So, as we seen yesterday, some filtering in the fields, putting some conditions on the field, like make the field as a mandatory to add, or the make a field in as a invisible, not to show in the form view. Though that field is in the form view, but it is not visible to front end, to the user. Okay. So addition in that filtration and restrictions. Today we're gonna start with the ODOO constraint. Now basically constraint means to put some restrictions or put some conditions or the filtrations. Okay. So ODOO provides different kind of constraints. Now it is on two bases. First one is a Python based constraint. Python constraint, and another one is a SQL constraint. There is two different levels ODOO will work. First, ODOO has the backend as a Python. So Python, we can put the constraint with the Python, or we can directly target in the database, as the SQL constraint is the direct database constraints. Okay, so we can do that in a two manners. So the first one is our SQL constraint. Now SQL constraint directly hits to the database. Always remember, it's directly hit to the database, particular table, particular field, whatever we are defining in that. Okay, so it directly communicate with the backend. Okay, so as we can see here, the syntax is there. For defining SQL constraint, we have to write underscore SQL underscore constraint. This is the identification for system to know that okay, this is the SQL constraint. Then opening square bracket, inside 3 arguments gonna be passed. For SQL constraint, 3 arguments gonna be passed. First one is the ID for that constraint. The first one you can consider as a ID. It is the constraint name, but we will consider as a ID for the constraint, because every constraint should have unique name. And in our case, when we are creating form view or attributes, at that time what is unique? It is our ID. So that's why first one is the ID for that constraint. Second one are the conditions and the constraint detail. And it should based on which field that should come here. And lastly, if that constraint or if that condition broke, then what message we want to display to user. So 3 arguments will come. First one is the ID, second one is the constraint with the field. Third one is the error message when that constraint rule is broke. Okay, so here we write one constraint for unique. Now suppose we have the XYZ object, in that there is a one field called name, and we want to make that unique for each and every record. It is not allowed to duplicate. So at that time what we gonna do? We gonna write the ID. So generally whenever we have ID in the form though, in the tree, we are following some particular rule, right? We are following the particular practice. Here also we gonna follow the particular practice. First of all, field name should come. So our field name is, and when I say field name, it means technical name, variable name. Okay, so that is the name. Then underscore, first name, then the underscore, and after that which kind of constraint we want to apply. We want to apply for unique, so we write unique in the short form, or we can write the entire unique also. That's up to you. If you want to use the short form, you can use short form. You can write the entire unique, you can write the entire unique also. Okay, now the first argument over, so our ID becomes name underscore unique, name underscore unique. Okay, the same way, let's take an example for the employee form. Now in that, which field can be unique all the time? Name? No, because in the same company with the same name 2 or more employees can be exist, but the unique field should be employee ID. It is always unique for each and every employee. So for that, suppose our technical name is employee ID, employee underscore ID. So our constraint ID would becomes employee underscore ID underscore unique. Okay. So first ID is clear now to everyone, correct? Okay, now we will move to the next part, which is defining the constraint. Now, here I write for unique constraint. That's why I write the unique in the capital letters. Always remember, whenever you are defining any constraint, you should write that in the capital letters. I am defining the unique. I want to make that field unique for each and every record. That's why I write the unique. Okay? Duplication is not allowed. It means it is a unique. So I use the unique constraint. Then inside the bracket, I have to define on which field it should applicable. On which field it should applicable. In this scenario, the field is name. So I write the name. Okay. Now again we come to our previous example, employee ID. So our constraint ID would be employee ID underscore unique. Then again we want to go for unique only, so we're gonna write the unique as it is. In the round bracket, instead of name, what we're gonna write? Employee underscore ID, because employee underscore ID is our technical name. It is our variable. Okay. And the last part, that is you are full free to do by your imaginations. Here name should be unique, so I gave the messages. You cannot have two users with the same name. See, I gave the messages. You cannot have two users with the same name. Same if I go for employee, then I can write the message something like one employee ID should belongs to one user only. One employee only. I can write that way also. Or I can just modify this message also. You cannot have two employees with the same ID. Okay. Here again I am repeating how to write the constraint ID. Constraint means your field name underscore constraint type. Here it's the unique. On other examples, we have not null also. Some of the fields are required. Not null becomes like a require. It will work as a required field. So it should have the value. Okay. Another ones are the primary foreign keys. Then check also. The different kind of constraints are available in the SQL, which you can Google it and search it by yourself. There is lots of constraints, and all of the constraints can be used in the ODOO with the use of SQL constraint. And whenever we want to define SQL constraint, we have to write this, so that system will get notified now. Okay, after is equals to it's a constraint. So I have to load on the database side. Okay. Now the second point will start. First we will see SQL constraint. Now we will see Python constraint. Okay. The constraint which is based on the Python. Now for writing this, there is a general information and some important points are there, theoretical points. As in the document, you can go through all the points, which basically says that how we are using, when we are using. Okay. Now it is a special case, so we are using one decorator, which is the @API.constraint. After that, as you can see here, the snapshot of one constraint record. Suppose it is a given one module, and right there we are writing the constraint. So first of all we have to note it down, and in the Python we are writing. So we are writing in form of method. So we should notify the system. We should tell the system that okay, this method is a constraint method. So for that we're going to use this decorator called @API.constraints. Here there is a constraints, whereas on the SQL side it is a constraint. See, on the both places it's constraints, or last S will come, not just T. Okay. Now again here we write the date underscore end, which indicates the field. On the previous one we take the example for name. Then another example I given, which is for the employee ID. Here it is applicable on date end. So inside my module there should be one field with the technical name, with the variable name as a date underscore end is equals to fields dot date time or date, whatever the type it is. Okay. After that, we are defining the function. So we write the def and we are checking that date. So we can give any name here, but it should start with the underscore. I am repeating this. Start with the underscore. It is not by the rule, but it is safe to do to avoid the conflicts further. Okay. So I suggest always start any constraint method with the underscore. Okay. And then self, which indicates the current record. Now I take a one for loop for all current records. Now you might be guessing that if I'm changing one particular record, then why do I need a for loop? It's a single record only. But suppose I'm changing something for entire attribute, then at that time my current record would be more than one. And if I don't write this for loop, it will conflict me further. So just avoiding that conflict, I am writing this for loop to be on the safe side. Now what are we doing? Comparing the date. See here record is a self. It means the current record. Current records date underscore end fill value is less than today. Here you can see fields dot date dot today, which is used to get current date. Current date. Okay. So I am just comparing that date underscore end with the given field. If it's the lesser date, it means it's in the past. I want to make a one constraint that whatever the date underscore end should have the future value always. Future value or the current date. If it's in the past, then I don't want to allow user to do that. That's why I'm writing this constraint and I'm checking this condition. Whatever the date user entered, it should, if it's less than today, then show them a one error message. The end date cannot be set in the past. Okay. So it's a Python constraint. It's very easy. Again, here's the link. You can refer this link for further process. Okay. More documentation, more clear ideas you can find on the official ODOO site. Okay. Here I write another example. Now as you can see, so sometimes it may happen that I want to apply the constraint not based on one field only, on the multiple fields. So at that time also possible with the Python also and with the SQL constraint also. Instead of one field, we're gonna define two fields separated by the comma. So here you can see I have field 1 and field 2. Now I want to set some constraints, set some rule that both field values should be different. If it's same, then don't allow user to save the record or process further. So that's why I write the API constraint field 1 and field 2, which indicates the system, okay, this is the constraint for field 1 and field 2. Again, def method name, okay. And inside the self, it means current record. Again, I am taking a for loop to avoid further conflicts. Okay. Now, as I told you the requirement, what is the requirement? Both field values should be different. So I am comparing record. It means my current record value dot field 1. It means current records field 1 and current records field 2. If both are equal, show them the user error message, validation error message. That fields field 1 and field 2 must not be unique. Must not be same or okay. So I write this constraint. If it's equal, it means both our values are same. So that's why I give the error message. It must not be same. Another constraint. I am giving you the example for integer constraint. Not integer constraint, the constraint on the integer data type. Now my amount has the integer or float in general numeric data type. Now I want to set a constraint that if its value is negative, then show them the error. Show them the validation message that negative value is not allowed or amount can't be negative. It always should be positive. So again write the API constraint on which field amount. Then we write the def and the method name. which is underscore check underscore something. So we can write any name of the method here. As I told you, initial underscore is not at all important, but I am suggesting to do to avoid further conflicts, as we are doing for here for the for loop. Okay, now I am checking current records amount value less than 0. It means negative, only negative, not even 0. Only negative value. If it's negative, then we are throwing the validation message that amount can't be negative. If it's 0, then this constraint will not work. Why? Because we write the less than 0, not less than equal to 0. So this is the topic for the day. Again, I am repeating shortly repeating the both things. Okay, we see the constraints. ODOO constraints. How many type of constraints do we have? Python and the SQL. Okay, and both are written in the Python file only. Both are written on the py file only. SQL constraint is also written in the py file only. After field declaration, we can write it. Okay. So SQL constraint is notified as underscore SQL underscore constraint is equals to then 3 arguments: ID, constraint, and the error message. So ID would be your field name underscore constraint type. Then comma, first, in the second argument also have 2 parts. One is the constraint type and in bracket your fields. Okay. Suppose I have to give the unique on basis of combination of 2 fields. So what I gonna write? Unique in bracket field 1 comma field 2. So whenever this both field value becomes same, at that time only the constraint got triggered. Okay, and the error message shown whatever we wrote. Okay, and second one is our Python constraint, which is basically defined in the method format. And to identify that, to notify the system, we are using the special decorator called @API constraints. Okay, and we're gonna write field 1 and the field 2. No matter how many fields we have, if we have single field, we write the single field. If we have multiple fields, we write the multiple fields. Then def underscore anything methods name. Okay, any methods name and self. This for loop is not at all important, but suggestible to do to avoid further conflicts for multiple record if changed. Okay, then we are checking different conditions. Here we are checking that both field values should be unique or different than each other. So that's what we are checking here. And with that, our constraint get over. Lastly, we have the validation messages on the every constraint, the Python side. Any questions you can ask.